Hi, kiddos. All right, so today what we are going to work on is how to solve addition equations. So we're going to talk today about Ned and his scale. So if we can see here, this is Ned. Ned is on one of these old-fashioned scales with some weights. He's there with about 12 extra pounds right here. Okay, on the other side, and right now we can tell that it's balanced because obviously it's at the same length here, height. On the other side, we've got 20, 40, 60, 70, 1, 2, 3, 4 pounds. So the first thing we want to notice is that the scale bar right here, this is where our tipping point happens. Okay, if this was heavier than this side, it would be lower, it would drop down, right? Whereas this side would come up. But right now they're equal, so they're the same height. So the first thing we want to do is draw our scale bar down our equal sign here. Okay, this shows me that there's a left side and there's a right side. On the left side, we have Ned here, and we're going to call Ned N. He is our variable. We don't know how much Ned weighs. He's what we don't know yet. And we have an extra 12 pounds. So Ned and 12 pounds is equal or the same as the 74 pounds on this other side. Ooh, my marker went freaky there. So what our goal here is to always to do is to get Ned by himself. Ned is our variable, so we call that isolating the variable. We want to get N by itself. So how we get N by itself is we do what's called an inverse operation. So we do the opposite of what's happening to Ned. Right now, Ned has 12 pounds being added. So the opposite of adding 12 pounds would be subtracting that 12 pounds. So what that would really look like is us just getting rid of these 12 pounds next to Ned. So what happens when we get rid of those 12 pounds is now all of a sudden Ned is way lighter than the other side. So our scale is out of balance. So to rebalance, and I want to fix this because that looks like a hot mess right now. To rebalance, we have to get rid of 12 pounds on this side. So we subtract 12 pounds on the other side. So what this is going to create is an equivalent expression. So we know that Ned now has no weights because if we had 12 pounds and we took 12 pounds away, that equals 0 pounds. So it cancels out and it leaves Ned, as you can see over here, all alone on the left side. And then what we have to decide is how much are we left with over here. So we say 4 minus 2 is 2 and 7 minus 1 is 6. So if we look at this, it should be that Ned is the same as 64 pounds. We've gotten that scale back in balance. 1, 2, 3, 4. So now they are equal again. Okay, so what we can do to check here is we can take our original equation, which was Ned plus 12 pounds. Actually, I'm going to change my color here so this is easier to see. We're going to go to blue. Our original equation was Ned plus 12 pounds is the same as 74. And so what we're going to do is we're going to take our solution here and we're going to substitute it in for our variable. So N becomes 62 plus 12 should be the same as 74. Now here's the key. We really want to actually see, does this work? So 60 plus 10 is 70, and 2 plus 2 is 4, and 74 is the same as 74, so we know that it works. So this is what it looks like without Ned. What we're going to do is take our original equation here, which is x plus 13 equals 71, and we want to get x by itself. So x is our variable here, so we want to isolate it. We want to get it alone. So we look and we see, okay, x is on the left side of our equation right now. So we need to keep it on the left side, but we need to get it alone. And right now it's attached to a plus 13. So in order to get rid of plus 13, we do the opposite. The opposite of plus 13 is minus 13. So whatever we do to the left, we have to come over here and do to the right because that's how it's going to stay balanced. Now we're writing our original or an equivalent equation. So we're going to draw our equals bar here. And we see that plus 13 minus 13 equals 0. So we've got an x by itself. Okay, so then x equals, now we have 71 and we have to subtract 13. So 71 minus 3 is 68. 68 minus 10 is 58. So our answer or our solution should be 58. In order to check this, what we can do is write our original equation, which is x plus 13 equals 71. We substitute in our solution over here, which is x equals 58. So wherever we see an x, we can put a 58. So 58 plus 13 should equal 71. And now remember, we really want to do this problem to see if it works. So 58 plus 10 is 68. 68 plus 3 is 71. So we have balanced our equation, so we know it's correct. Okay, I want you to pause and try this problem now. Okay, so the first thing that we're going to do is we're going to draw our line down our equals bar. We see now that y is on the right side, but that doesn't matter. Y still needs to be kept alone. So because y has this plus 22 attached to it, we have to get rid of this plus 22, and we do that by doing the opposite, which is subtracting 22. If I subtract on the right by 22, I have to subtract on the left by 22. Then I'm going to draw that equals bar so that way I get my nice new equation. Okay, so plus 22 minus 22 equals 0. So on the right, my y is left alone. And now I subtract over here. So 41 minus 20 is 21. And 21 minus 2 is 19. So my solution should be that y equals 19. Now, if you haven't checked your work, I want you to pause now and check. Okay. So now let's check. We check by writing our original equation, which was 41 equals y plus 22. And then we substitute in our solution. So this is our solution, was that y and 19 should be the same. So wherever I see a y, I can put a 19. So now here's where I actually want to do the work. Let's see here. 19 plus 20 is 39, and 39 plus 2 is 41. So I see that my equation is balanced, and y equals 19 is my solution. So I'm going to assign to you some Khan Academy problems. I want to see that you're showing your work correctly, that is using inverse operations, that we're drawing our scale bar and we're finding our solutions.